Hey guys, Mrs. Diaz here. We are looking at day 4 of our practice. We're going to look at homework 5.3.3, an advanced qualitative look at rates. I've got my pen. So whenever we're looking at these graphs, because it's asking right here, sketch the acceleration versus time graph for each of the velocity versus time. So we're given velocity and they're asking us to find acceleration. Remember that acceleration is the derivative of velocity. And whenever you think of derivative, you really want to think of slope. So anytime you hear that word derivative, we're just thinking about slope. Okay? So take a look at this piece here. This is like a linear piece. What's our rise over run? It looks like it's up 1 over 1. So the slope is going to be, I'm going to say that this is 1. Slope is 1. Just a straight line. I'm going to make that a little bit straighter. There we go. So just a straight 1 because that's our rise over run. That's our slope here. It's a clean 1. And then it changes. And it changes dramatically. It's like increasing and then a sharp turn to decreasing. What would you say the slope is of this section? The slope there would be a negative 1. So it's a positive 1, then it's negative 1, then back to positive 1. And that's going to be our picture for the acceleration of this graph. Remember, we're thinking about slope. So here's a quadratic. You see how the quadratic is flipped upside down? It's been reflected. So it's a negative quadratic. I know it's been some time, but in class we talked about how if you have a quadratic, the derivative of a quadratic is linear. And I don't know if you can see. But derivative of a quadratic is linear. The derivative of a linear is constant. And the derivative of constant is 0 because a constant is a horizontal line. So there's a rise of 0. It's not rising, it's just running. So rise over run is 0 because it's not rising. 0 over any number that you can think of. But 0 divided by any number is always going to be 0. So we start off with a quadratic. Derivative of quadratic is linear. Derivative of linear is constant. Derivative of a constant is 0. What if you started with a cubic? Derivative of a cubic is quadratic. Derivative of quadratic is linear. Derivative of linear is constant. And derivative of constant is 0. So you always have to start from the highest degree and go down 1 degree. Now, because this is a quadratic, we know the derivative is linear, but because it's a negative quadratic, it's going to be a negative linear. Now, take a look at the maximum point right here. This is the highest point. It's called the maximum. What would you say the slope is at that maximum? The slope is coming to a nice flat surface, so the slope here is going to be 0. So the slope here is 0, and then notice how it's increasing, meaning it's going to be above the x-axis. Then it turns into decreasing below the x-axis. And that's going to be a linear function that's the derivative of the parabola. All right? Now, the last one, I'm going to stay with this color. The last one is, I'm not sure what kind of function this is, but we can see how right here it starts off flat, meaning it's going to be a slope of 0. And then notice over here at this point, it also ends up kind of flat. So it's going to return to 0 at this x-coordinate. The slope is 0. Notice it's increasing, and then it gets, I don't want to say that's a straight line, so it's not undefined, but it is increasing. And then it's at its maximum here because then it starts to decrease to get back to 0. So it's going to come back down like that. And let me kind of clean that up because I want it to be more symmetrical. I want it symmetrical, meaning it's almost like, woo, like that. Okay, this point right here is the highest slope, and that's going to be that maximum. So it looks something like that. And that's going to be the acceleration graph for this velocity graph. Remember, we're thinking about slope this entire time. So now let's take a look at some other examples. I'm going to go ahead and scroll down. I'm going to skip these. This is a matching exercise. See if you can take a look at the slope. These are going to represent the slopes of the first three graphs. So see if you can match up the derivative with the original function. Okay. Number 3. This is another matching exercise. It says match the situation descriptions with the corresponding velocity versus time graphs in figure 16. So here's figure 16. These represent velocity versus time. I'm gonna play with all these. Let me see how this works. Oh yeah. Velocity versus time. These are all velocity versus time. And let's read the descriptions, okay? So I remember A and B giving you guys kind of a hard time, so why don't we leave those for last? So letter C says a student bouncing on a trampoline. But you can imagine a student jumping up and down, up and down, up and down. And so of these graphs, I'm going to say this one's going to be clearly E. So we're done with E. Here is our classic physics example, a ball thrown straight up. So if you have a ball and you throw it straight up in the air, it's going to create a nice quadratic function. Now that quadratic is a nice upside down U shape, right? That's our parabola. And we talked about this earlier. What's the derivative of a quadratic? Well, the derivative of a quadratic is linear. And so our linear function, because it's a negative quadratic, it is a negative linear. So this is going to go to B. Done with B. Remember that the ball thrown up, that's our height of the ball. So we want to figure out what the velocity is. Velocity is the derivative of the height or position. All right, letter E. A student confidently striding across campus to take a pre-cal test. Really wish we could be at school right now and see you guys come into class ready and excited for this test, because everybody would be this graph, right? Yeah? Okay, anyways. So when you're walking with pride, you're just walking at a constant rate. And of the graphs here with that constant rate, that's going to be C. F. An unprepared student walking across campus to take a pre-cal test. That's none of you guys, because I know you guys are ready for this test. But when you're a little more hesitant, you're kind of like going back and forth, like, oh man, you're like excited, you're going, and then you're like, wait, maybe I need to rethink this. I believe that letter D is going to go with this description. And that's because they're just kind of unsure. You see, they're back and forth. But that's my D right there. All right, let's go straight back up to A and B. So it says a car quickly leaving from a stop sign. So quickly leaving meaning you're starting at 0 and then your velocity just starts to increase. Notice this one starts to increase in velocity, but then it kind of slows down and goes back at a normal pace. So I'm going to say F goes with that one. And that means the last one, this last graph, should belong here. A car steadily leaving from a stop sign. So notice it's like going and then it's like kind of backing off a little bit. It's not going at a speed that's increasing rather quickly. So I'm going to go with A. And I'm going to finish right there. You guys continue practicing. Don't forget, slope is derivative. And I'll see you guys soon. Bye.